Welcome everyone. Today we are going to talk about MongoDB data modeling, but not in the way you have seen it before. We are not going to discuss basic CAD operation or simple schemas. Instead, we are diving into the architect's mindset, how experienced engineers think about the data model that need to survive real production workload. So here is the fundamental shift in thinking. Data modeling is not about organizing collections. It's about three things: access pattern, scale boundaries, and failure modes. Before you write a single line of schema code, you need to answer five critical questions. First, what are your top three read queries? Because 90% of your traffic will come from these. Second, where will write amplify? One For example, one user action might trigger 10 database writes. So that is a problem waiting to happen. Third, what need to scale independently? Your user profile, for example, your user profile and order history might grow at completely different rates. Fourth, what changes frequently versus rarely? So you need to ask this question. For example, a user email changes maybe once in a year, but their shopping cart changes every minute. So this is one example where certain things are changes frequently. And the last and fifth rule is, what is your shard key candidate? Because if you get this wrong, you will be rewriting the entire database layer later. If you skip these questions, I guarantee your model will break in production. It's not if, it's when. So we will be covering MongoDB data modeling. So there are following patterns of MongoDB data modeling. I will be creating two parts for modeling this, covering this modeling pattern. So in this video, we will be covering this five pattern today. So let's start. Let's start with maybe most fundamental decision in MongoDB, which is embedding versus referencing. So now beginners thinks about this is in term of size. If it is small, embed it, and if it is large, reference it. That is wrong. Architects thinks about it differently. The question is not about size, it is access pattern and life cycle. So embed when data is accessed together and reference when data evolve independently. So here are two rules you can see in the screen. Here are two rules you need to memorize. If your query always needs parent plus child data in the same request, embed it. For example, when you load an order, you always need to you always need the order item. So you can embed the item inside order. But if the life cycle is independent, then you can reference it. For example, user information and their order history have completely different life cycle. The user updates their profile maybe once in a month, but creates orders weekly. These should be referenced, not embedded. So let's see the embedding pattern first. Let's look at the concrete example on the screen of the embedding pattern. Here is an order document. You can see here, there is an order document. An order document with item embedded directly inside it. So you can see that items array is embedded inside this order document. First, orders are always read as whole. So when you show an order to user, you never show just the order without the item. It always together, right? So second, items are never queried independently. So you never run a query that say show me all item across all orders. So items only make sense in the context of their parent, which is order here. And the third, you get atomic rights. When you create or update an order, it is a single document operation. No transaction needed here and no complex coordination as well. So this is MongoDB at its best, simple, fast, and reliable. The entire order in one document here. So the entire order is one document, one write and one read. But embedding is not free actually. So let's talk about the trade-offs. On the pro side, you get incredibly fast read because everything is in one document. You get single writes operation, which means better performance and simpler code, and you don't need transactions here. So which is a use for both performance and complexity. But on the con side, you can see you need to watch for document size growth. MongoDB has 16 MB of document limit. And even before you hit that, large documents slow down. Second, you will have some duplications. If product information is embedded in order and the product name changes, you won't update historical orders. And that's actually often what you want, right? So and third, partial update become harder if you want to update just one item in an order. So you need to be careful with your update operations. These are not deal breakers, but you need to understand them going in, right? So this is about embedding pattern. Now see the let's understand the referencing pattern. Here we have users in one collection and orders in others, connected by the user ID. Why does this make sense? First, user updates should not rewrite orders. So if a user changes their email or address, you don't want to update potentially thousands of orders document. That is expensive and error prone. Second, orders and user scale independently. So these are independent basically, and their scaling is also independent. So you might have millions of orders, but only thousands of users, and they grow at different rates. And third, you avoid document bloat. Each document stays small and focused. The trade-off are different here. You get independent scaling and smaller document, which is great, but you pay the cost of join like queries. When you need to order data with user information, you have to do two queries or use a lookup operation. That means multiple round trips to the database and handling joins in your application code. It is not wrong. It is just different, right? So you are trading some read complexity for write simplicity and better scalability. So that is referencing pattern. Now let's talk about the next pattern, which is extended reference pattern. So this brings us to one of my favorite pattern, the extended reference pattern. This is used heavily by multiple companies like Amazon, Netflix, and many other large scale systems. So look at this order documents. We are storing a reference to the user. Okay? We are storing reference to the user. But we are also duplicating the user's name right here in the order. Why? Because this solves a real problem. When you display order, you almost always need to show the user's name. And if we used pure referencing, every order query would require a second query to get the username. That is expensive at scale, right? But we are not embedding everything about the users. We are only duplicating fields that are real heavy and rarely change. The user's name here does not change often, but it needs in almost every order display. So the key insight here is controlled duplication. There is duplication, but which is that is in controlled manner, which we keeps the source of truth in the user's collection, but we duplicate a specific field for performance. This requires consistency strategy. When a user changes their name, you need a background job to update orders. But that is okay because it happens rarely. The architect rule is simple: duplicate, read heavy, rarely changing fields. Now let's move to the next pattern, which is bucket pattern. Bucket pattern is critical for time series data. You may be heard about time series data. So imagine you are storing user activity logs or sensor reading or some click events. So the anti pattern is to create one document per event. So if you have a million of event per day, that is a million of documents, a million index entries, and a million writes operation. This does not scale. The bucket pattern groups events into buckets. So in this example, what we are doing, we are bucketing by users and date. All of all of a user's event for January first go on to the one document. Why does this scale so much better? There are four reasons. First, you have far fewer documents. Instead of millions, you have thousand. Second, fewer document means fewer index entries, which means faster writes and less memory uses. And third is MongoDB can compress these document better because similar data is together. And fourth is this is sort friendly. You can sort by user ID and get even distribution. The trade-off here is that each bucket can grow, so you need to roll over logic. When a bucket hits a certain size or a time boundary, you close it and start a new one. So the architect rule here is to optimize for right amplification, not purity. Yes, this is more complex than one document per event, but it is a different between it is it is a difference between a system that handle millions of events per day and one that handle a billion. So this is about the bucket pattern. Let's move to the attribute pattern. So the attribute pattern solve a specific problem. When your schema explodes with sparse dynamic fields, imagine you are building an e-commerce system. A phone has RAM and battery specification. A shirt has fabric and size. A food item has expiry date and nutritional information. The bad approach is to create fields for every possible attribute. So you end up with hundreds of fields, most of them null for any given product. This is terrible for indexes and query. So the attribute pattern normalizes these into a key value pair. Each product has an attributes array with just fields that actually apply to it. Why is this better? First, you can create a sparse index on the key field. So you can efficiently query, find all products. So you can efficiently query like finds all product where attribute key equal RAM. Second, the schema is flexible here. You can add new attribute types without altering your schema. And third, filtering is efficient because you are only storing what is actually there. So the trade-off is slightly more complex queries. Instead of querying product.ram, you query where attribute contains a key of RAM. But the benefit far outweigh this cost. So the architect rule here is when your schema explodes with optional fields, normalize them into the attributes, means key value pair. Okay, so in this video, we have covered till attribute pattern. So in the next part, we will be covering other pattern as well. So please, thanks for being in the video.